A fence 12 feet tall runs parallel to a tall building at a distance of 6 feet from the building as shown in the diagram. Okay, so find the length of the shortest ladder that will reach from the ground over the fence to the wall of the building. So we have this 12-foot fence. We have some big old building here. This is like a side view, it runs along like that. It's 6 feet away. The fence is 6 feet away from the building. And we want to put a ladder that'll reach over the fence and touch the building, right? We want the shortest ladder that will reach from the ground over the fence to the wall of the building. So what, right? Because what the shortest one that'll just barely make it over, touching the top of the fence and reaching the building. So notice if you're doing a project and you're like, all right, I need to go over that fence to reach that building to work on something, a window or something on that building. How do you know what size ladder you need? What's the minimum size ladder, the shortest ladder that will reach that? How do you calculate that? So very practical for all kinds of, real life things, technical things that people do. Not if you're just handyman just doing a project, you would just grab, but and you're a big construction company and you're building things and doing important things, you would need to calculate things like this. Okay, so how do we do it? Well, we're just going to do the setup on this one. We're not going to get all the way to the end. It says, find a formula for the length of the ladder in terms of theta. So they put an angle theta in there for us. Hint, split the ladder into two parts. There's the answer. How'd they get that? Well, what they did is they said, okay, let's find just this part right here for stuff. Just that. That'll be part one. This is part one of the ladder. And then we'll do the other part two in a second. How do we find that? Well, you remember trigonometry, right? I hope. So with trigonometry, this side here is the opposite. Here's the right angle. So this side is the hypotenuse because it's across from the right angle, and this side is the adjacent. Remember that from trigonometry? And so we can set up an equation. Remember your trig functions? Remember SOHCAHTOA from trig? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we want to find part one here. And we have that as 12 feet. We don't know anything about the adjacent. Skip that. So we want some trig relationship between the opposite and the hypotenuse. You see that? Opposite and hypotenuse. Why? Because I want to find the hypotenuse. I want to find out how long this piece of the ladder is. That's part one. And I know the opposite, which is the height of the fence, which is 12. So I need a trig relationship involving opposite and hypotenuse. That's sine. Sine is opposite and hypotenuse. So that means, whoops, I'm going to write the equation. Sine of theta is opposite of hypotenuse is going to be, it's going to be 12 over part one of the ladder because that's opposite and that's hypotenuse, and sine is opposite of hypotenuse, right? It's 12 over part one. And so now I can solve that equation for part one, just multiply by part one. Oops, it's kind of scribbly. Over one on both sides. Just multiply by part one on both sides. Cancels out here. And I get part one times the sine of theta equals 12, right? Because these guys canceled out. And so now finish getting part one alone, divide by sine of theta. It's a little scribbly right there. Sine of theta, boom. Part one is 12 over sine theta, or you could say 12 cosecant. Either one's good. It'll take this one or that one. Let's say 1 over the sine is the cosecant. Do you remember that from your trig days? I'm gonna make that better. Either one. Either one's good. That's part one. But now we need part two. Okay, so here is, let me make this a little bit hone in here. This is part two. So we only have this part of the ladder so far. That's why it said split the ladder into two parts. Here's part two. And so what we can do is come in there and make a tiny, teeny tiny little triangle right there. Womp. And that, I don't want that. I want this. Whoopsie daisy. There we go. So I made a little triangle, a little right triangle, right? So, and again, we're going to do the SOHCAHTOA thing, and we're going to say, oh, and the angle's the same. This theta will move right up into here. Nope, not enough room for that. Better job. Come on. That's the same angle theta. Why? Well, because this line is flat and this diagonal, so come up here with another flat line. It's going to be the same angle theta. Okay, and then this side is the opposite, and this is the adjacent, and this is the hypotenuse again for this little triangle up here. And what do I know? I know the adjacent down here is 6 feet. I know this part is 6. Drops right down here. The adjacent must be 6, huh? So now I want a trig relationship involving the adjacent and the hypotenuse. Again, I want part two. I want the hypotenuse. And this time I know the adjacent. I don't know anything about the opposite. So I want a trig relationship involving the adjacent. Sorry, that it didn't write that adjacent very well. Adjacent. I want a trig relationship involving the adjacent and the hypotenuse. Which one of these involves adjacent and hypotenuse? Cosine, adjacent, and hypotenuse. So I go, oh, okay, that's cosine. So then cosine of that little angle theta is going to be 6 over part 2 because that's adjacent. Because that's adjacent over hypotenuse, isn't it? And cosine is adjacent over hypotenuse, right? It's 6 over part 2, adjacent over hypotenuse of that little right triangle. Okay, so now we need to solve for part 2. How do you solve for part 2? You multiply both sides, just like we did before, by part 2 over 1. Both sides by part 2 cancels out. Bring it down here. We get part 2 times the cosine of theta equals 6. Last step to finish solving for part 2. Divide both sides by cosine of theta. Boom. So part 2 is 6 over the cosine of theta, or 6 secant. They don't remember, if you remember from trig, either one. 1 over the cosine is secant. So that's, and then we just add that, we just add up part 1 and part 2. So here they go. Here's part 1. Here's part 2. 12 cosecant, 6 secant, right? 12 cosecant, 6 secant. Or, I'll say, or you could do them the other way. You could just type in 12 over sine theta plus 6 over cosine theta. That's totally fine also. And that's a formula now for the total length of the ladder, right? Part 1 plus part 2, the total length of the ladder in terms of the angle theta. And that'll help us. We're going to stop right here on this one. This is just a setup. But then in another problem, we'll finish it up. We'll take this equation, then we'll say, okay, now let's find the angle theta that'll make the length of the ladder, L, this is L equals minimum. And how do we minimize something? You know, we take the derivative and we set it equal to 0. That's the next part, to find the smallest ladder that'll fit over the fence and hit the building. So there we go.